Okay, so this is a correction to my previous problem for question 9, part 2, and the reason why is because I did it wrong, so let's do it correctly this time. Okay, so we're taking the integral of this function. This is negative. The conjugate, this is the same thing as the conjugate for the complex form of this. I'm sorry. The conjugate is just the negative form of the imaginary part. It's very important in mathematics. And 2 pi squared. So, assuming m equals n, that is just e to I n phi times e to the negative I n phi divided by 2 pi between 0 and 2 pi. This is 1 d phi. And the integral of 1 over 2 pi is just phi from 0 to 2 pi, which is 2 pi over 2 pi and 1. If you do that calculation, you should be able to figure it out. Now let's do this one. Okay, so as we did before, when you multiply exponents, it's the same thing as adding them. Because I'm not the greatest with integrals, what I like to do is simplify this integral in the sense that I like to take out what I'm integrating with respect to. I n minus I n 2 pi d phi. This gives us e to the I n minus I n. Sorry, ignore that. Times whatever this is, so I n minus I n. But frankly, we don't really need it. Do you know why? Because if we take e to the I m minus I n of 2 pi minus e to the 0 times anything 0, all over 2 pi over 1 minus I m minus I n. M and n are integers. Anything of an integer times 2 pi is 2 pi, let's just say big N. Anything that is 2 pi n is always basically 0, because it's a revolution. You start here 0, it's 2 pi, 4 pi, 6 pi, 2 pi to the n. This is just 1, and 1 minus 1 is 0.